Hey everyone, before we start the video, I just wanted to take a moment to let you all know about how to change some of their settings on YouTube. If you need captions or if you need to slow the video speed down, here are some instructions on how to do that. You can pause the video now and go ahead and change your settings as you need. Otherwise, just continue on. Thank you. Hey everyone, in this module, we're going to be using R to analyze our data. And I can understand that using R might be really intimidating, but I want everyone to know that I'm going to work really hard to help guide you through this process. And I've made this video to really help give everyone a leg up in understanding how we're going to be using R and how to navigate code and alter code. So one of the reasons that I wanted to use R is because in biology, ecology, and fields even outside the biological sciences, people are using R to analyze their data. And there's a few reasons for that. One of the reasons is that R is an open source software, so anyone can download it, which means that it's really accessible to people. The other reason is that when you have a set of data and you want to analyze it, sometimes you don't have the tools in Excel to analyze those data. And R has a lot of extra tools that you won't find in Excel. In addition to that, R makes it really easy to manipulate, make subsets of your data, and just look at your data really easily. So this video is going to be actually using the data from last week's pre-lab, and we're going to essentially do the exact same things. We're going to make a subset of the data, and we're going to create a scatter plot graph with a trend line, add the equation, R squared value to that graph, and then get the p-value doing a regressional analysis. So I hope you find this video helpful, and please use this video as a way to help you through the pre-lab quiz. So once you create your RStudio Cloud account, this is the page you're going to get to. This is your workspace. And one of the things that I want to point out right away is this account usage. So you get 15 free hours in any free account. And I want to point this out because we're going to need 6 of those 15 hours for lab, and the rest of the time is what you can use for your pre-lab activity. You're not going to be using this much outside of lab time and your pre-lab time. So we shouldn't have to worry about actually making the 15-hour mark. But I want to keep this in mind because if you decide that you want to mess around in RStudio, I'd like to ask that you create a separate account that is not related to the class material so that you don't go over your project hour times. So, getting ready, the first thing you're going to want to do is click New Project. And you can name your project up here. If I would just name it Module 2 because we're going to be going back to this. So it'll take a little bit to load up. Once we get to this page, the first thing that you're going to want to do is click File, New File, RScript. This is going to open this section where you're going to be pasting and modifying RScript. The next thing that I would want you to do is create a new folder. And so in this case, I'm going to call this pre-lab. Click OK. Now we see this pre-lab. Then click the folder, and now we're in the folder, and you're going to upload the data that I asked you to download from the quiz. So click File to upload, choose File, and here is all ready to go the Module 2 data. So click Open and click OK. So once we have all of this ready to go, you can go ahead and paste the code that I gave you to use. So this first part is actually setting our desktop. So it's essentially saying, like, where's our working space saving things to? And in this case, oops, cancel. If I go to my project, so it says cloud project, instead of this saying pre-lab test, I'm going to change it to pre-lab and click run. This means that everything that we are saving is going into this pre-lab. Okay, so the next thing that we're going to want to do is we want to add these things right here. In the parentheses, what we see are these things called packages. And if we go to this tab over here, click packages, you can see what packages are already installed in RStudio as is. But these tools aren't all of the things that we want. So we're going to have to install extra ones. So for each of these things that you see in the library, you're going to have to click install, type in that name, select it, and then click install. And down here in this console, you'll see the action starting to take place. It might take a little bit to do, so don't worry about it. It'll just take a little while to load. So go through and I'm going to go through and add all of these. I'm going to cut the video so that it kind of just fast forwards into the point where all of these packages have been installed. Alright, so it looks like our packages were installed. If you want to double check to make sure a package was installed, you can click the Packages tab and then go ahead and look for the package name. Now there's two ways to actually make a package active. You can either click this blank check mark next to the package, or you can go type in library parenthesis, the name of the package parenthesis, click next to that and click run. The other way that you can do this, if you have a lot of different packages to load at once, you can type all this up, then highlight all of your text, and then click run. So moving down in our data, you're going to see a hashtag upload data. Anytime you see hashtag, you should think, oh, this is a note. The hashtag tells R that this is not code, it's just something that whoever wrote the code is putting in there to tell its users something about the code. In this case, I'm going to be using hashtags to leave you all notes saying things like, hey, you need to do this, or don't forget to do this in the code. Just little hints to help you navigate through the code. So if we go to files, we've already uploaded our data. So now we can go ahead and go to import dataset. Here you're going to see this read CSV. This is telling the system to read a CSV file. And that's the type of file that our data is in. And then following that, you'll see this long bit of code saying where that file is. So if we look here, we can see cloud project pre-lab, which remember that's the name of my folder, and then our data there. So we're typing in the same thing, code project pre-lab, or whatever else you named your folder, and then the name of the actual file. Following this, you'll see header equals true. This is just saying that that first row of your data set is just the titles of each of your columns. Now, before we actually import the data set, we want to store it as something. So if we ever want to recall or extract data from this data set, we want to just give it a name. So in this case, I put the name phonology, and I use this arrow to say store everything on this side of the arrow as phonology. So this stored as phonology. So if I highlight this and then click run, we're going to see in our global environment phonology pop up. That's what I named it. And if I click it, you're going to see all of those data that we saw in that Excel file here. So if you click back on your tab, I want to point out before we go any further, anytime you use a capitalized letter in R, it's important that you, whenever you want to use those data again, you capitalize that letter, because a lowercase p in this case is not going to pull up anything as opposed to if you use a capitalized P. So I'll show you now. If I type in phenology and just click, oh, it capitalized it automatically for me. Click enter, and then click run. It says error object phenology not found. Now if I capitalize that P and click run, all of our data are actually going to be showing up at the bottom here. There's a lot to see. So make sure you're very careful about capitalizing because you're going to not pull in the correct information if you do not change any of that, if you are not consistent with what you're capitalizing. So now remember, these data are filled with a lot of different families and species, and we want to essentially do the same thing we did last time, and we want to subset the data. In order to subset our data, we use this command filter, and we type in phenology. This is telling us where we want to filter the data from, and then I want to filter by location, and I'm going to change this to United Kingdom. And it's important that these are in quotations, because if it's not in quotations, it's not going to pull from the right area. And then we have an and, because I want both the United Kingdom and the family Lycaenidae. If I wanted to, let's say, go by species, I would need to change family to species and then type in the species I'm trying to isolate. Again, capital letters as spaces, periods, all of that is important. So when you're going in here and actually selecting things, make sure if there's a space, you include the space. If there's an underscore, you include the underscore. All of that is important. And so I can go ahead and highlight this, click run. Again, I use that store as, and then I did Lycaenid. And now we can see that Lycaenid has shown up here, and all of the Lycaenid family bits are here. All right, so we have our data subsetted, and now we want to do a graph. So this might look a little bit intimidating, but I'm going to walk you through it. So when we draw a graph, we use this program called ggplot. Then here we say data. This is again where we're saying we want the data to be pulled from. We are going to pull from Lycaenid since we want it to be that Lycaenid data. And then we type in what we want to be our X and what we want to be our Y. Remember that the question that we had asked was, does temperature, the number of cold days, affect the median emergence time of Lycaenids? So X, the days of the cold days, are the independent variable, and Y, the emergence time, would be our dependent variable. Now we have this little plus sign, and it goes to geom point, and this is actually right here the scatter plot points. So you could change the size of the points, the color of the points, or even the shape of the points. It's up to you if you want to try and mess around with those things. You're going to have the R code accessible to you, so if you mess up somewhere, you can always go back and get the old code and put it back in. Then we have a plus sign, and you see this geom smooth. This is actually telling the graph to add a trend line, and this is saying that we want to add that regression line. This is telling the color. This is saying if we want to include the standard error, so we say false, we don't want to include anything. And then it's telling the type of formula we want. So in this case, this is just saying that we want our y equals mx plus b. and then another plus sign, and we have labels. And following that is the title, whatever we want the title to be, comma, whatever we want the X label to be, and then comma, and then whatever we want the Y label to be. Again, it's really important that you have these quotation marks. If you delete any of the quotation marks, it's not going to show up for you. So just so you know, the quotation marks are important. So if I highlight all of this and click run, we're going to see a graph show up, and I'm going to move myself up into this corner for now. And we can see our graph show up. So remember we said for that color of the trend line to be red, and you can see that our labels showed up. And now what it's missing is our equation. So before I go on to the equation, I just want to show if I change this color to green and I change this color to orange and I run this again, our colors change. So again, I'm going to leave it up to you if you want to change and mess around with that, but it's completely up to you. So you'll notice that the code that we have right here, if you compare this to where we just drew that graph, everything is the exact same thing. We're just going to add one extra bit. So we add that plus sign and then this stat poly equation. It's saying that we want to include this equation for the line, and we're also going to include our R squared value. So if we highlight this and click run, now you can see that our equation for the line has showed up. I just want to do a quick note that this format is y equals b plus mx, but it's the same thing because you can put the b on the other side. This right here, the 0.186x, 0.186 is our slope, and then that 139 is our y-intercept. And then you can see our r squared value here. Now we're going to get to analyzing our data. This is actually really easy and simple. There is a code for our regression, and that's just this LM. And you do a parenthesis, and this is our format. So I put this up here. The Y is first. So Y, median emergence time, that's our dependent variable, and then a tilde, and then our X. And the X is days below 7.2 Celsius. It's our independent variable. And then a comma and where we want these data from. Now, I'm going to store this as stats because this is essentially analyzing the data, but it's not going to give us any information until we ask for a summary. So we store it as stats. You can change this to whatever you'd like. I'm just going to use it as stats for right now. And I'll go ahead and highlight this and run it. And then I do summary. So this is asking for a summary of the stats information. You can click run, and you'll see down in your console, we got all that same information we got before. Right here at the bottom, it's going to have the information we're looking for, our p-value and our r squared. So that is where our stats are. Now I want to let you know that let's say you're writing some code and you decide you're going to name something else with the same name. Please be very careful because anytime you use the same name, so if I were to do something like stats and this and 1 plus 1, and I were to do summary stats, it's not going to give us the same information anymore because now stats is equal to 1 plus 1. So whenever you are running code, be very careful and mindful of what you are storing and naming things. So anything that you put to the left of this arrow, make sure you change it appropriately so that you don't lose any of your data. Again, if you ever mess something up, you can always upload the code again and fix things again. It's not a problem. All right, so the last thing I'm going to show you is how to save your graph. So here in the plots section, you can click export and save as image. And you can see our directory, which we set earlier, Cloud Project Prelab. It's going to save to that Prelab folder. You can name it whatever you'd like. So I'll just name it Graph 1. You can change the dimensions. Make sure you click Maintain Aspect Ratio if you ever decide to change that, because if you change it, you might get a really wide graph. If you don't want to maintain the aspect ratio, that's fine. Unclick it. And then you just click Save. You can also change the type of file you want. We'll just keep it as a PNG. And save. And now if we go to Files, we'll just start here. Click our Prelab. You'll see our graph is here. You can double click it and it'll pop up. And if you want to save it to your computer, which you're going to have to, you can right click it on your screen and save as, or if you'd like, you could take a screenshot. It's up to you. There's only one other thing that I realized I did not mention earlier. When you're installing a package, so I will just pick a different code or different package, make sure that this install dependencies is checked. Essentially, what you're telling this command to do is make sure that if this package needs other packages to run successfully, that you want those also installed. Outside of that, the last thing I'm going to show you really quickly is how to create another working table. So if you just click File, New File, and RScript, you basically open a new RScript area. And what I'm going to suggest for you all when you're actually doing the modules is to just open your Prelab module and create a new working area. Anytime you want to create a new working area, you can do that. You have as many tabs as you want. You are able to close these data sets and then you can reopen them by double clicking over here. The reason I'm suggesting that you just open a new area is because then you're going to have to reinstall all the packages every time you open up a new project. So this will save us a little bit of time. But outside of that, I don't have anything else to show you, and I really hope that this was helpful. Thank you.